Hello everyone, this is the recording for 3.1. Now 3.1, we briefly talked about in class that chapter 3, sorry, I got to get a drawing going. Okay, so this is the pen, use this color, I think use this. Okay, so we talked about 3.1 or chapter 3 in general. We said that it has two things to be worried about. Now the 3.1 now we talk about is the definition. All right, so definition of rational numbers. Rational numbers. So as a matter of fact, we also talked about that chapter 3 is basically just talk about rational numbers. Rational numbers. Now the first thing is we talk about definition. Now the second thing we talk about the operations. So for the students that had me in class already, probably think this is just repeating, but this is also made for some other classes, so just please bear with me. Now the definition will also talk about what is a rational number. That means that any number can be written into a fraction, right? Into a fraction. And then A and B, as a matter of fact, has a so-called restriction, or A and B also needs to be defined in the way that the rational number does not look like something like 7.6 divided by say 3, for example. Okay, so this does not, seriously, by strict definition, this is not a rational number. You cannot really just write it this way. So what that means now first of all, B cannot be 0, because if B becomes 0, then this number is not defined. Now there's also another condition, which is A and B. It's all integers. And today in class, we talked about how to write it into a domain notation. This one you will be later on learn about it, but I just say, here you go. For A, now A belongs to integers that we use the big letter Z to represent the set of the numbers, which is a set of integers, that's a Z. So now B also belongs to the Z. So then that means A and B are both integers. So that's a definition, and we did do some interesting practice to realize what is the rational numbers. So please also try to focus on the repeating decimals, such as 1.14. Okay, repeating. So then this is a rational number. Now, how do I write this into a fraction? How do I write it into a fraction? We did not have time to go through it in class. Some students I can see is able to do that. So please try this by yourself. How can I write a repeating decimal into a fraction? All right, now in this video, I also wanted to talk about a couple of things that just as a general about the important part of 3.1. Now, for example, determine common denominator. This is absolutely the preparation for the coming section. Now, in class, I find it very interesting. Now we figure out that we have two strategies to come up with the common denominator. Now, one strategy is just find the lowest common multiple, right? Now, let me show just a couple of examples. You should know how to do this, but just in the video, I show it again. So then what is between 15 and 20? What is a common lowest common multiple? So now here I go, I make a list. So here is a 15. Now here is 20. Okay. Now 15 add on to another 15, or 50 multiplied by 2, that becomes 15 and another 15, that is 30, right? Now 15 add on to another 15, then becomes a 45. So I thought, okay, well, then why don't I do it here? After a couple of try for 15, number 15. So 20 add on to 20, now it's a 40. Okay, well, they're getting closer, but they're still not the same. Okay, now 45, now add on to another 15, 60. Oh, now here we go. This will add on another 20, and then that is 60. Beautiful. Okay, well, that is their lowest common denominator. All right. So, and also from this kind of way of doing, then you can say now 15 is, as a matter of fact, 60 is 15 multiplied by 4, right? And then this one is 20 multiplied by 3. So therefore, when you change this into 60, you know that is 15 multiplied by 4. Therefore, your top is to be 8 multiplied by 4. That's what you do there. And then the other one would be, now will be 20 multiplied by 3. Therefore, your 11 will multiply by 3, right? So then this time, no matter you add them or subtract them, at least you got your common denominator, and then you're just going to worry about the top. All right. So I thought, okay, well, we can use this lowest common multiple to do everything. But sure enough, now really, take a look at this guy. 84 and 54. I try to use lowest common denominator. It absolutely just drives me wacko. Okay, so let me show you. So the next one, we're saying we don't use lowest common multiple. We use a prime factor. Prime factor. Or factors. All right, that's our second way. But people say, well, no, I just want to stick to this way. Okay, you want to stick to this way? Let's try a large number. And you will be completely going nuts. Like well, at least I did. Okay, so I have 84 here, and I have 54 here. Okay, now 84, add on 84, 168. Okay, add on another 84, 252, and then 336. And I thought, oh my goodness, this is already large enough. Like, let's take care of this guy. This guy here is 108 and 162, and then 216, and then 270. So, oh, are they getting closer? No. As a matter of fact, you can see then it's like add on another 54, it becomes 378, and this one goes to 420, but they're still not the same. And then let's go to 504. They're still not the same. And I just thought, you know what, I'm going to stop. I'm not doing this. This is a little bit too ridiculous. So then another way, which is now I think is absolutely good for so-called large numbers. So let me use another color. Okay. So that is called a prime factor or prime factor tree. So let me factor 84 first. Okay, now 84. Now first one always divided by 2. Okay, so divided by 2, and then that is 42. All right, now still divided by 2, and then that is 21. Okay, well, not here. I cannot be divided by 2 anymore because it's not an even number. And then the next smallest prime number is 3. Okay, so then divided by 3, and then 7. Okay, they're all prime numbers now, so I cannot go any further. Okay, so in fact, this number can be written as 2 to the power of 2 multiplied by 3 multiplied by 7. All right, now let's take a look at 54. Okay, I'm going to do 54. Now 54 factor tree, again 2, and then this is right away there's 27. Okay, so then in that case, I have to try 3. Now 3 and 9 and 3 and 3. Okay, so now 54 can also be written as 2 multiplied by 3 to the power of 3. All right, so now between these two numbers now is written in the prime factors way, then we have to pick the highest, not the lowest anymore, now the highest. The highest for 2 is the power of 2, because here the power of only 1, but then there's power of 2. We'll have to pick power of 2. And then here I got 3, and here I got a 3 to the power of 3. I have to pick that one. And then here I got a 7. I don't have a 7, then I still have to pick the 7. This one here means 7 to the power 0. If any of you know this, we'll get to there, okay? So then the 7 to the power 1, the 7 to the power 0, then of course I have to pick 7 to the power 1. So therefore, my common denominator, my lowest common denominator now is 2 to the power of 2 multiplied by 3 to the power of 3 and then multiplied by 7. You know how large this number is? This is 756. This is the lowest common denominator. So if I keep going, yes, here I would finally reach the 756. Here I would reach 756. I lost my patience. But if some of you do not want to learn this prime factor tree from this to figure out the common denominator, you stick to this, well, you will get there. It's just very, very tedious. Okay. Now here also it says, okay, well then how do I figure out 84 is how many multiplied by how much to get 756? Well, let's see this. So 84, before 84 you have 2 to the power of 2, and you have that. So as a matter of fact, you only needed to multiply by 3. 3 to the power of 2. You see, because from the difference here, it is you have another 3 to the power of 2. So then you just have to multiply. It's 84 multiplied by 3 to the power of 2, which is 9. So 84 multiplied by 9 is that. So then your top will be 5 multiplied by 9, right? Now your 54 here, 54 is that 54 you have 2 to the power 1, but there's no 2 to the power of 2 as we picked, right? 2 to the power of 2. So you got to multiply by 2, another 2, and then you have to multiply by 7. So that means 54 needed to be multiplied by 14. That gives us 756. Therefore, your top 7 has to be multiplied by 14. Hey, that's what we do. Now, the last one I want to talk about is this question is very interesting. So this question is that you're going to write a number. Is this question or is this another question more complicated? Oh, question number 8. So question number 8 is a little bit more challenging, okay? So you're going to write a fraction between these two numbers. So these top ones, these A, B, C, D, is not as challenging as the down here. So then let me just take a look at this number to try to make sense. So now 5.123, 1, 2, 3, 1, 2, 3, right? Now the next one is, let me change to a color, change to another color. Okay, now next one is 5.1234. 1, 2, 3, 4. Well, I think I should line up a little bit better. So now what I realized is here, 1, 2, they're the same. 1, 2, they're the same. 3 and 3 is the same, but this is a 1, this is a 4. Okay, well, in that case, and then we got 1, 2, 3 again. So then if for this number here and between these two numbers, if I fill in something, then that should do the trick. So then how about 5.123.2? Well, then this number is in between this number and this number. This is what I thought. Okay, and you might have another way to do it, and please do the homework. And I think this is about 3.1.